Our project is titled Adaptive Control System for HVAC Optimization using Large Language Models and Fuzzy Logic. Our main objectives of work are first, to develop a LLM-enhanced Fuzzy Logic controller to generate adaptive HVAC rules. Then, to validate the system performance using real-time testing by measuring total energy consumption, temperature controller stability, and how quickly the system adapts to changes of the environment. Finally, we compare the performance against the traditional HVAC system with respect to our LLM enhanced Fuzzy Logic controller. Here, for the LLM, we integrate the LLM OpenAI GPT-4o mini version for intelligently generate the new fuzzy rule set. We fed the traditional fuzzy rule set and the final result generated to the LLM, and the model produces a new better fuzzy rule set and a membership function for the LLM based controller.
We built a simulated room environment with a configurable heat load and ventilation setup. User can select a specific room configuration and then apply a dataset of temperature and humidity variation. For example, real-world environmental data we downloaded as CSV files. The system supports 5 different controllers: constant control, on-off, PID, standard fuzzy logic, and our proposed LLM enhanced fuzzy controller. For each run, the system plot output like room temperature, relative humidity, control signal, and total energy usage, all on the same graph for easy comparison. The constant on-off and PID controller function in their standard form, acting based on fixed logic without learning. For the traditional fuzzy controller, we defined a basic rule set manually. These results are shown in light blue on the simulation graph. In our proposed method, we use OpenAI GPT-4o mini language model. We provide it with the traditional fuzzy rule and the simulation result obtained using those rules. The LLM analyzes the relation between the rules and system behavior, then generates an optimized fuzzy rule set along with updated membership functions. This forms the basic of our adaptive controller.
So these are the final results. So in here we have shown the output from different kind of controllers, and for reference, the set point for the controllers, the temperature is 22.5 centigrades and relative humidity is 45% or 0.45. So as you can see, almost all the controllers has been able to come to reach the desired temperature values, but when it comes to the relative humidity, the AI controller shows very promising results, and also the on-off controller has been able to reach that, but there are large fluctuations. And when it comes to the control signals, this shows the control signals. So obviously on-off has only on and off for the cooling and the heating, and also for the humidifier. But these are the control signals for the PID controller, fuzzy logic controller, and the AI optimized controller. So relative to these two controllers, we can see that the AI optimized controller, or the LLM optimized fuzzy logic controller, has rather smooth control curves, and their amplitude is very low, so the cost of control will be lower than the other two controllers. And we can see the same results in the energy consumptions. So in here as well, the optimized controller has very smoother energy curves rather than the other two. So the components will be have better lifetime, and also but when it comes to the total energy consumption, the PID controller has a clear advantage, but the AI has, or the LLM has been able to optimize to reduce the power consumption relative to the normal fuzzy logic controller. But when come to the psychometric chart, we can see the on-off controller is not very concentrated in the results over the time period, but the other three are relatively good, but the AI optimized controller has been more compact or very steady in the results. So in here we have shown that we can optimize a fuzzy logic controller using LLM, and we have demonstrated it for HVAC. But we believe this has many applications, and we can use this concept in other control applications as well. So these are the results from our project. Thank you very much.